and welcome to another episode of FooBar. In today's video, I want to go over some of the most important concepts of step functions so you can understand the videos that are coming up to this one. This video is part of a series on step functions videos, and you can find the whole playlist in the description box. I will leave it there. And in the previous video, we introduced step functions and when to use it and its benefits. So now let's go into the main concepts. In the introduction video, we said AWS Step Functions is a serverless workflow service that makes it easy to coordinate multiple AWS services and your own applications into scalable serverless workflows. Step functions use visual workflows that are made out of steps. Each step performs a discrete function, such as running a Lambda function or making an API call. So that's what we said in the first video. So now you might be wondering, what is a step? As we said in the definition, step performs a discrete operation. It can be calling an AWS service API, like a Lambda function, or getting something from Dynamo, or from S3, or putting something there. There is over 11,000 of those, and over 220 services that it integrates directly. Or it can be calling a third-party API, as it was shown in a previous video. I will leave all the links to the videos I mentioned in the description box. Steps are divided into types. So we have states that are tasks, like the ones I will call an API. But there are other types of states as well that does other things, like change the flow of the state machine. There are 8 types of states in the definition of a step functions. So let's go into more details into what are these kind of steps. Let's start with the task state. The task state performs work, does a task. This could be calling a Lambda function, which is a very common use case, but you can also use task states to wait for a worker, like something that is doing something, like a long-running job. For example, you can wait for another step function to complete and then return the results. And we will see in a further video some integration patterns and things that you can do with the task states. So I will not get into the details here, but a task state can also be used to invoke an API. So when you see that HTTP request, it will be a task state. It can be also to call other AWS services, third-party services, and all that. So in the screen, you can see now get item API. So that's how it looks, the task state for this particular example. So it's getting an item from Dynamo. Then we have the parallel state that can be used to create parallel branches of execution in your state machine. A parallel state provides each branch with a copy of its input data, and it generates an output array with one element of the results of each branch. So it combines everything in a nice package result. If a branch in the parallel state fails, then the whole thing fails. And here in the screen, you can see an example on how we can define a parallel state with 2 branches. Very small, but it's not that complicated. We can have multiple branches. Then we have the map state, and the map state can be used to run the same set of steps over each element of an input array. While the parallel state executes multiple branches in parallel, and all those branches can be different, the map will execute the same steps for all the elements in an array. So when you work with the map state, you can build this dynamic fan out and scatter and gather. Basically, you can send the same operations to all the elements in an array and then get the results at the end combined into one place. So this is a very powerful state. Map state has 2 modes, the distributed and the inline mode. So let's look at them. Let's talk about the inline map state. When we work with the inline map state, we have a number of 40 concurrent iterations. This means that we will take 40 elements of the array and run them in parallel, and then the step function, the workflow, will proceed with the next 40. So that's something you have to have in mind. And you can set this maximum concurrency to something else. So if you don't want 40, you can have it in 5, but the maximum is 40. And the output of the map state in this case will be a combination of all the iterations. We need to wait until all the how many elements you have in the array to have the output. And if something fails in the map, some of these iterations fail, then all the iterations are terminated. So if you want to define that, in the screen I have an example for you. You have the type map, and then you have to say that is the inline type. And then you can basically define the steps that are going to be run. Then we have the distributed mode, and the distributed mode is very powerful. It supports up to 10,000 concurrent iterations. So this is monstrous, it's huge. As well, you can configure the amount that you need. So if you cannot handle 10,000 because your downstream services cannot handle that much, you might set it to 100 or 1,000 or whatever you can do in parallel. The input for this type of state can be passed from the previous state. So you can pass a S3 bucket or destiny in S3. You can pass a comma-separated value or a JSON file. So it can iterate over all the elements in a bucket, all the elements in an array of JSON, all the elements in a CSV file. So it's very powerful, and it's for working with a lot of data. The iterations when we are working with a distributed map will happen in a nested step function. So each iteration will be its own execution. So you will see that as a child workflow of your main execution. So that's something you will have to take a look when you're running these distributed maps. And the output for this distributed map is a JSON where you will find all the results, and that can be stored in S3. I have a full video dedicated to the distributed map, so I will link it in the description box. Then we have the choice, wait, and pass state types. So let's look at these different states, and this will help you to move the flow of your state machine. So first one, we have choice. Choice is like a big switch. So basically, that's this branching logic. So if your input is and it matches this, it will go through this branch. If it's B, it will go through that branch. Typical switch. Then we have a wait state, and this one will add a delay in your state machine. So you can add a wait for 10 seconds, 60 seconds, whatever you need. And then the state machine will stay there in that state, basically waiting until the time goes by, and then it will move to the next step. So this is sometimes handy when you need to wait for something to happen, and you can use this. But later on this series, you will learn about some integration patterns for more efficient ways on waiting, so you don't need to run these waiting loops. And finally, we have the pass state, and this basically passes the input to the output without doing any kind of works, without calling any APIs. And this state is very useful when you want to transform the input to another output, so you can manipulate it and do some changes. So you will see that a little later on in this series. And finally, we have two more state types that are the succeed and the fail. A succeed state stops the execution successfully, so you will see in your execution history that everything was good. A fail state will stop the execution like, nah, everything is bad, and it will mark it as a failure unless you add a catch block to it. So that's something you can have in mind. So now that we have covered the different kind of states and how they look in Amazon State Language, ASL, and its visual representation, I think it's time to go very quickly over state management. You already heard a little bit about inputs and outputs when I was talking about the different types of states and how these are manipulated, but there is quite a lot going on when you're working with workflows. I will not go super into the details because the documentation is very good. I will leave you the link in the description box, but I want to give you a quick picture so you understand what is happening and also to know what to look for when you're struggling with these things. So a step function execution, when you start a new execution, you will pass a JSON as an input. You can use it or you cannot, but that's there for you. So that's the state machine, the workflow input. And that input will be passed to the first state in the workflow as a JSON. And that's the state input for that particular step. Then the state will be any kind of type and will do things. It can be a task type and then gets a different output. And then you will have the output. and then that output will be transferred into the next state input, and that's the flow. Then if we look at more details inside what is going on in a particular state, let's look at the task state, that is the one that has the most features. We can see that there is many fields when you're working with the Amazon state language, and things that you can manipulate the inputs and the outputs to get exactly the results that you want. So this is very important when you are working with data, because you don't want just to call a Lambda function to manipulate this JSON. You want to take advantage of all the features that step functions provide you in order to manipulate this data and pass the right state to the next step and to get the right result at the end of the state machine. So the following diagram shows how JSON information moves through this task state. So the state input will basically go into the next step, that is the input path. And here you are able to select which part of the JSON, of the input JSON, you are going to pass to the task state. Sometimes you don't want the whole thing, you want just a bit, and you can do filtering here. Then we have the parameters, that is what the task state will receive, and then the task state will do its magic. And then we have the resource selector and result path. The result path selects what combination of the state input and the task result you are going to pass to the output. And finally, when you are working with the output path, you can filter the JSON output that you want to move forward out of your state. That's the state output. You can manipulate it one more time. So when you're working with step functions, you don't need to touch all these fields and manipulate them all, but it's good to know what you can do in each of these fields when you need to do that, and in order not to lose the state. Another important concept when you're working with state machines is the context object. The context object is an internal JSON structure that is available during an execution, and it contains information about your state machine and its execution. This allows your workflows to access information about their specific executions. You can access the context object by using the $sign from the different parts of your ASL at the definition of your state machine. So you can call it with this $$ dot whatever is the name of the parameter that you want from the context. I will leave you the documentation on the different parameters that are available in the context. And finally, when working with state, we have intrinsic functions. I mentioned that you don't want to have to call a Lambda function all the time when you're doing data manipulation. And intrinsics are a way to apply these basic functions that you have available in programming languages to help you to process the data inside your state machine, inside your workflow. There is many kind of types of intrinsic functions available, but you can find functions to manipulate data, to manipulate arrays, to manipulate strings, to do math operations, to create new IDs. So simple tasks that we need to do all the time. I will leave you a list with all the intrinsic functions available so you can find it in the documentation. So here you can see a slide where I'm doing an operation with intrinsic functions, and you can see how I'm formatting that URI. So state dot is the kind of way to know that you're calling an intrinsic function inside your state machine definition. And you can see here that I'm formatting a string. And the string is like a URI, and there has a dynamic variable description bucket name that it comes from the definition substitutions. This is inside some template. And then I have the payload region and payload key that are dynamic attributes inside the input state that I'm basically inserting in specific parts of my string to form that URI. Then I can go one level more complex, and you can see here how I'm writing that command. And here you can see also that state dot, you can see state dot format, state dot array get items, and states split string, string. And here you can see how I nest 3 different intrinsic functions in order to build this string. In this case, it's a command, an AWS CLI command. And basically, I'm first splitting an URI and then getting an element in the position number 3 of that URI, and I'm putting that inside my command. So they look a little bit confusing at the beginning, but they're very handy to know. The last concept I want to cover in this video is the workflows types. Step Functions has 2 different types of workflows that you can select depending on your needs. We have standard and Express. Standard workflows are ideal for long-running, up to 1 year. You can run it. They're durable, they're auditable, and you can retrieve the full execution history using the Step Functions API up to 90 days after your execution completes. The standard workflows also has this exactly one model where your task and states never run for more than once at one time, unless you have some retry behaviors specified in your state machines. This makes standard workflows really well suited for orchestrating these non-idempotent actions like starting EMR clusters or processing payments or things like that. Standard workflows executions are built according to the number of straight transitions, so that's something to have in mind when you work. And I will have a whole video about cost analysis later in the series where we'll dissect all the things that you have to have in mind when working with step functions. Then we have express workflows. Express workflows are ideal for high volume event processing workflows such as IoT data ingestion, streaming data processing, data transformation, backends. They can run up to 5 minutes. So we go from 1 year to 5 minutes. Express workflows employ at least once model. Basically, they will run at least once. Then if you don't have idempotency in your functions, you need to implement that. This makes express workflows ideal for orchestrating idempotent actions such as transforming input data, storing something in Dynamo, or performing kind of data transformation. Express workflows are built by the number of executions, the duration of executions, and the memory consumed while they are running. I will leave you more documentation about the types of workflows in the description box. And that's the video for me today. I know it's a lot of information, but I think it's important to understand these concepts so you can move forward in this playlist, in this series, and be more confident that you understand step functions. The next 2 videos we are going to start building. The first video will be with AWS SAM, so how to build step functions with SAM. The next video will be how to build step functions with CDK. So depending on the framework that you choose, you will find that there. So subscribe, enable notifications so you know when those videos are coming. If you like this video, give a thumbs up. If you're enjoying this series, give a big thumbs up, put a comment. It's really nice. YouTube loves your comments. And here you can find the playlist if you have not checked the description box. And also here you can find the video about the distributed map if you want to learn more about the design. So I'll see you in the next episode.